the American School of Rio de Janeiro, and the Association of American Schools in South America, in collaboration with Inspire Classrooms of Missoula, Montana, at the GIN Conference in Rio de Janeiro, present Dr. Steve Running.
So, good evening. We're here in Rio de Janeiro, in the Escola Americana de Rio de Janeiro, our school of Rio de Janeiro. And we're going to do an interview for you right now for our GIN conference. And we wanted to ask you some initial questions. First, what is your research related to? Can you explain that to us, please?
I write software for NASA satellites to understand the health of the biosphere.
Interesting. And as a new generation, how did your path lead to who you are today?
Well, I started with a training in ecology, and I started working with the American NASA Space Agency in 1981, and it was from beginning work with the Space Agency that I started studying global ecology. Because in my early training I just measured single trees, and so I worked in forest ecology originally, but then as I started working with NASA, we started thinking of the whole world.
Thank you very much.
Good afternoon, Mr. Runnings. My name is Joshua Hyde, and before we continue, we understand that you have a presentation that you wanted to show us, is that right?
Yes.
Great. Why don't we hand that off to you first, and then we'll continue with questions later on.
Oh, I think that's a good idea, because I think some of my presentation will answer some of your science questions, but I think some of the ideas I suggest will bring different questions out that I hope you'll find motivating. So I'm ready when you are.
Great, we're ready.
Okay. This is now my official talk. Let me start by saying I have been to Rio one time for a conference about 10 years ago. Yeah. So I've been there. I know a little of where you are. So, all right, we have to get to work here. And so, do you see my first slide?
Yes, you do.
Good. So you see my title. If I was in college now, what would I major in? I find that when I talk to students of high school and early college age, that this is in many ways the most interesting thing I can speak to, because that is what's in all their minds, is where should I take my career? So with this talk, I hope to give you some ideas of, if I was your age, what would I be thinking of? So here goes. Everything that we know about global warming started with this famous curve called the Keeling curve. And this was the initial measurements of atmospheric carbon dioxide that started in 1958 and continues to this day. And I knew Dave Keeling personally. The slide shows him going up a chairlift with me. The reason it's important is before this curve, humans could fool themselves into thinking that we were tiny little ants on a gigantic planet, and that there was no real way humanity could influence the climate of the entire world. But with this curve, he showed that that was not true. He showed that we were already, back in 1958, starting to change the chemistry of the climate forever. And so every year, the CO2, the carbon dioxide, was going up in the global atmosphere. And that's what this slide showed. Now, I imagine in your science classes that you've studied something about climate change. If not, I hope after this this session that maybe your science teachers do. I don't have time to give a complete explanation. So this is a short explanation of basically the fundamentals of global warming, the fundamental physics of global warming. And it's simply that different types of molecules let light from the sun come through the atmosphere, but the thermal or heat radiation coming back from the earth is a different wavelength, so it's blocked. And so it's blocked just like a greenhouse. It's blocked like if you park a car out in the sun with all the windows rolled up, the car gets really hot inside. It's because the light from the sun went through the glass, but the heat energy, the thermal radiation, could not go back through the glass. Well, these principles of greenhouse gases are not a new discovery. A guy named Svante Arrhenius completely figured this out in 1896. So over 100 years ago, scientists understood this principle of molecules that have this greenhouse effect of trapping heat energy. And so Arrhenius in 1896 speculated that someday in the future, as humanity burned coal, which back then was what they were burning, releasing carbon dioxide as exhaust, he thought, well, sooner or later the world's going to start warming up because of these greenhouse gases. So it's important for us to recognize that the basic science around global warming has been understood for a century. And so when we as scientists now try to understand where the global climate is going, we simply follow the components that control this, as we call it here, radiative forcing. And what that really is the radiant energy going in minus the radiant energy coming back out. And this is the principle we use of studying the global climate. Now, this one slide is a summary of all that science and basically identifies the things that control this balance of radiant energy coming in and out of the Earth's system, all the different factors that control it. And what you notice is that there are aerosols in the air that change this balance. There's changes in albedo, which is actually simply the reflectivity of the surface. A white surface reflects light back very easily. A dark black surface does not reflect light and absorbs almost all the light. And so when we study the Earth's surface, we see how reflective it is and whether that's changing. The biggest thing that changes the radiant energy balance of the Earth, you see at the top of the slide, and that's carbon dioxide first, and then other greenhouse gases like methane. And so this is how we know quite accurately that the Earth's system is now trapping more radiant energy than it was maybe 100 years ago. This amounts to, this additional energy being trapped amounts to only about 2 watts per square meter. And the best way to think about that is you folks have Christmas trees at Christmas time in your homes?
Some of us do, yeah. Right.
Okay.
A lot of us are real.
Right.
Imagine
Imagine the small little lights that you have on your Christmas tree. Imagine one of those lights around over each square meter, which is a square meter like the size of your desktop. Imagine one of those Christmas tree lights on every square meter of the whole world. That's the additional energy now being trapped. All right, now the summary of what that is doing to the global temperatures is simply what you see here. Over the last 30 years, we're just seeing progressively temperatures going up. more and more. And I won't dwell on that any longer. I think you see this in news reports, and it simply is the consequence of all this additional radiant energy being trapped. So scientifically, we have many measurements that illustrate this additional heating. It's not only looking at air temperature. Probably some of the most important are looking at how melting of ice is accelerating. Now, I don't think there's any ice in Brazil at all. If I remember you, I don't even think you have mountains with snow on top, do you?
Not the whole year, but in the winter in the south, and if it's very high,
Right.
like the Itatiaia Hills in Rio, they can have snow.
Yeah.
Okay, so in the very south you have some higher mountains that have some snow. We have very good measurements of snow and glaciers and sea ice around Antarctica and the Arctic Ocean. Why ice is so valuable for following climate is it's easy to see. So we started having global satellites in about 1980. So not all that long ago, the first satellites went up. But even those early primitive satellites could measure the difference of ice and land or ice and water. So some of our best measurements over the last 40 years are coming from satellites measuring melting of ice. One of the principles that we've learned that when I was your age, scientists didn't understand, so this is a really new understanding of the Earth system, is that almost all of this additional energy is being absorbed by the oceans, not by the atmosphere. The atmosphere is a very tiny part of the climate system, but it doesn't have the capacity to hold heat that the oceans do. We now understand that the ocean circulates in this long, slow, as they call it, conveyor belt, moving very slowly, maybe 1 kilometer per hour, but stirring the heat of the ocean all around the planet. And so we now know that this extra heat that has been being trapped for the last 50 years, I need to go this way. That extra heat is almost entirely going into the ocean. And so we now understand that this heating of the Earth system has been accelerating since 1980, and that it very clearly most of that heat is going in the ocean. Now, I mentioned to one of the questions a few minutes ago that climate scientists think the most important global warming impact is going to be rising sea level. And so this graph simply shows the progressive rise of sea level. Let's see if I can do that. Are they seeing the same thing? All right. We expect sea level by the end of the century, so within your lifetimes, we expect sea level to be 1 meter to 2 meters higher than it is now. And you think 2 meters, and that is going to be a serious influence, and this will be within your lifetimes. We think this will be the biggest impact on humanity of everything concerning global warming. Another major factor that is of concern for oceans is the ocean is acidifying as it dissolves carbon dioxide into the water. Now this really is just the fizz in soda pop, is CO2 bubbles in soda pop. And so it seems like it's harmless, but what it's doing is making the ocean more acidic. And so we are worried that coral reefs and a number of ocean plants and animals are going to have more trouble surviving in a more acidic ocean, and particularly animals that grow a shell, like clams and prawns and corals. And so that's another issue that we think will be very big in the future. Now, as I go through some of these problems, I hope some of you are at least imagining career possibilities. If you're interested in ocean biology, the very first thing you might get interested in is studying ocean acidification on fish in the ocean or something like that. As I said earlier, what we've been able to follow best over the last 40 years on a global scale has been the melting of ice, because even our earliest, simplest satellites could see that clearly. So this just shows that the volume of the sea ice up at the North Pole is just, this is interesting because this is backwards of, has been going down over, I'm going to drive myself crazy trying to do that. Over the last 30 years, we're clearly seeing the sea ice of the Arctic Ocean shrinking. And of course, this is the other end of the planet from you folks, but the ice in Antarctica is in a similar situation, that we're seeing the ice and the glaciers melting at a continuing rate. Now, I don't want to spend our time talking about more and more global warming impacts. Now I'd like to talk for the rest of my time on some of the big issues I see and things that I think you all might get ideas for your own career choices. One of the biggest issues is what they call global food security. Can we really feed everybody in the world in the coming decades? And so we're very concerned as global scientists that we can analyze, can the world grow enough food? The big problem starts right here. Where is the global population going? We know, let's see there, that's right, we know that right now there's about 7 billion people on Earth, and we know by 2050, and so only about 35 years from now, we expect there to be 9 billion people. So that's 2 billion more people just by the end of your careers that we have to be able to grow food for. And this also implies that of the 7 billion people on Earth now, not all of them are adequately fed either. So we imagine that we may have to virtually double the amount of food being grown in the world over the course of your careers. So this is a big global challenge, literally, to grow enough food for the human population of the future. I could show you a number of studies that try to understand this in a more quantitative way. This is just projections for maize, rice, wheat, and soybeans from now to the year 2050. And the dotted lines in all cases are the projections of the need, of the requirement for food, and the solid lines are the projections of what will actually be available. And you see in every case they expect demand to be greater than supply for these foodstuffs in the future. And so a huge career opportunity for anyone is going to be advanced agriculture, improving efficiency of agriculture. I mean, that's going to be an ongoing issue throughout your entire lifetimes. One of the things that then gets particularly interesting, and Brazil is right in the middle of this issue with ethanol. I think Brazil produces more ethanol than any other country in the world. And I think it's almost all from your sugar cane. Did I do that?
Sorry about that.
I forgot to kick it on. I think those are intercom.
Please continue. It's
Okay. a big, a
the-
big. All right, so a big issue, and I think a big issue for Brazil is going to be to what extent you use for your agricultural land to continue for ethanol production as a fuel or as food for people to eat. I mean, this is going to be an ongoing choice that your nation and every nation is going to be making. And I don't want to suggest what's right or wrong. I'm suggesting this is just going to be a huge topic during your career times to make these decisions of how to make optimal choices on food versus fuel. One of the things we worry about most when we talk about food production is that around the world, a lot of agriculture is based on irrigation, and a lot of irrigation is depleting groundwater supplies in a way that won't ever come back. When you're irrigating from a surface river, rainfall and snowfall from the following year will replenish the river. But when you drain water out of a groundwater supply deep underground, that took thousands of years to build up, and once it's gone, it's basically never coming back. A good example of that is, I'm standing right in the middle of the biggest. This is an area in India that we know is depleting groundwater at the rate of something like 4 centimeters per year. And so it's clear that when this groundwater is empty, a huge amount of agricultural land will suddenly stop. And so it's just one example of the issue we see worldwide with global food supply. Let's talk about energy for a while, because of course burning fossil fuels is the foundation of the whole problem. So what do I see for the future, and what might be things you all could get interested in? First, this is simply a look at human carbon emissions since 1990. And the only point I make with this slide is to show it keeps going up and up and up. So right now, humanity worldwide is continuing to accelerate CO2 emissions. And so this is just the simple facts. When we look at the sources of those emissions, we see here that all the basic fossil fuels are going up a bit, gas, oil, but what particularly has spiked in the last decade is burning coal. And we as climate scientists see that having the world stop burning coal is probably the single biggest issue we have right now, because stopping burning coal will more quickly slow carbon emissions than anything else we could possibly do. I don't think Brazil burns much coal, but I might be wrong on that. That might be something you all would want to look into.
Brazil relies mostly on hydropower.
Yes, and when we don't have, like we had the problem with water this year, we had some gas usage, but
Okay.
not coal.
But no coal. All right. We have a resident expert here.
Good. Well, you're lucky if you're not burning coal, because that's something that other nations will really have to stop. And incidentally, that huge acceleration that we see starting in the 2000, right about there, has been almost entirely in China. And so this is now where there's big political pressure on China that they have to dramatically slow and ultimately stop burning coal. And they're starting to agree with that. So we are now seeing policies coming from Chinese government stating their interest in slowing coal burning. We're waiting to see it show up in the actual data, but they are agreeing that that's the first solution to our problems. What we're now understanding is something like 50% of all the known oil reserves that oil companies have found worldwide, and 80% of the coal that is available worldwide, we can't burn, ever. The global political leaders have basically set a target, a threshold that they really don't want global warming to exceed 2 degrees C. And so the climate scientists have put that into their climate models and basically back calculated how much fossil energy can still be burned to stay below 2 degrees. And that's the conclusion, that the majority of oil and almost all coal has to stay in the ground forever. This is becoming a huge political deal in the US now, because oil companies are realizing that they either are going to wreck the planet, or else they're going to, within their lifetimes, they're going to stop producing their main product. So this is getting very interesting to watch. And so we have this kind.
So, could you say that one more time?
Yes,
Louder.
in Brazil,
Yeah.
from all our energy, only 5.8% comes from coal.
Okay. Mr. Running, did you hear that? Around
Five-
6% of Brazil's energy comes from coal. Yeah, 5.8. It's just the exact data
Oh.
point. 5.8%.
That's good. Your coal use is very low, which means it will be easier for you to stop burning coal entirely. You'll have alternatives for that small amount. In China, something like 70% of their current electric power comes from burning coal. So for them, they have to make a massive switch. And yet that's something they're willing to start into. So I use this slide to just make that simple point, that the world's going to have to go from this sort of energy source and be looking at the energy sources of the future from renewable sort of things like wind power, solar power, hydropower, nuclear power, possibly, but we have to just quit burning fossil fuels. And so economists and energy specialists have been doing projections here again to the year 2050 of how could we reach that point by 2050 where our fossil fuel use is maybe not zero, but dramatically minimized. And these are the sort of trends that they see. And by far, if you look at this graph carefully, the biggest change is stopping burning coal. And secondarily, stopping burning gas, but by far the biggest is stopping burning coal. And so that really needs to be a national priority for every country on Earth that burns coal for electric power. And I will say that's what most coal is used for. It's is to generate electric power. And so it's something that what we look at is other ways of generating electricity. It's really as straightforward as that. What are some of the ideas for generating that electric power? Now we talked about, I showed slides of wind turbines. Here where we live, we have hundreds and hundreds of wind turbines already in certain parts of the country that are windy. In fact, thousands of wind turbines already exist in the U.S. and are being built every day. Solar power, I've got solar panels on my house. And so there's more and more just normal Americans putting solar panels on their houses. So that is already started. And we'll continue. Both of those are some of our strongest possibilities. Well, what are some other things? This is an example of possible use of biomass. We have forests that a lot of the forest wood is just burned in piles as waste wood. And we think of, why couldn't we be burning those in portable generators and generating electric power rather than simply burning the wood into the sky? I think a similar issue is with your sugar cane, that there's a lot of waste from your sugar cane, huge, millions of tons of not the sugar stalk, but the rest of the sugar cane plant that very possibly now are just wasted or just burned in piles. And so it would be something to look into, of whether there's a bioenergy possibility there. One principle that I see is going to dramatically change from my generation to yours is, in my generation, we always thought of electric power as coming from huge power plants, whether they're a huge hydroelectric dam, whether they're a huge coal plant, whether they're a huge nuclear plant. What I see in the future is going to be totally different. The idea that possibly every single house will have solar panels, that communities will have small hydropower dams for just their community, that there'll be clusters of wind turbines in the hills. And so what we think of more generally is that power production will be decentralized instead of huge big plants that then send power throughout the country. Possibly every building will have some small amount of power production of its own. That's going to completely revolutionize electric power generation and electric power consumption. And so a good career path would be electrical engineering, that's for sure. But anything having to do with electric power is going to be very big in the future. Another really huge change that I see coming, that you're at your age, you're just entering the point of, in America, kids your age all want to get a car. Used to, all want to get a car. We see a future where there'll be driverless cars, where people won't own a car. You will simply schedule a car to come get you at your house and take you to work. And when it has taken you to work, it'll go take someone else to work, rather than just sit in a parking lot all day. One of the incentives for this is thinking how much our personal cars sit around all day long doing nothing for the few minutes each day that we actually need to get to work, need to get to the store, and need to get home. I am seeing an absolute transformation in the logic of personal transportation in the future, where people don't own cars, they simply schedule when they need to get somewhere, and these driverless cars just come get you. You may hear in the news, Google is huge on these Google cars. They are putting massive effort into these driverless cars. They've already found they're safer than cars being driven by people. People as drivers make mistakes, and yet these computer-controlled cars don't make mistakes. And so that's going to be just a massive transformation. And it will then transform the way we design our cities. We don't need parking lots everywhere when we have this kind of design. I watch the design of high-efficiency homes nowadays. These are student projects that are part of a competition in the United States every couple of years from architecture schools. And they're imagining these home designs that are completely self-contained, that they don't need any outside energy source. They recycle their water. They have all their own power supply. These are homes of the future. I think last topic, I think this is my last topic, is that I see massive need for better ideas on recycling material. We throw so much stuff away that just goes in landfills, and it's just simply unsustainable for humanity. I mean, plastics. These pictures here are metals and aluminum, but look at the background picture, are old computers. Almost nothing in an old computer is currently recycled. They're just smashed flat in a landfill. That's crazy. And so there's endless new careers in figuring out better recycling. So the final point I want to make to you students is, maybe you're not an engineer or a scientist. One of the biggest things we need is to figure out how to do international cooperation. How do we get the whole world to agree to do these things? Global warming is a global problem. Every single country, every single person contributes to it. How are we going to get a collective agreement and governance to actually have a global community that functions? Right now we have the United Nations that tries, but unfortunately is very unsuccessful in actually producing global consensus to do anything. So we need political scientists and international policy experts, foreign language experts, economists. Many of these things are in the social sciences that are every bit as much needed as these technical fields and engineering fields that I spoke to about these other issues. And so I see that your generation is going to need to figure out how do we govern and coordinate activity of the entire planet across 194 countries. The last thing I'll put in is the Pope. And this Pope, like no Pope I've ever seen before, is willing to talk about hard science. He is in America today. He's in Washington, D.C. He will speak to our Congress tomorrow. And if you have not read his encyclical from back in June about climate and the earth, then that should be a class project to go read that, because he wrote at a level of technical detail I never knew any pope would ever write. And he fully understands that the fate of the planet is riding on all of our collective decisions. And so I did this 5 stages of climate grief. I did this article back a few years ago when I was on an IPCC committee, and I'll just end with these summaries of how people go from denial, like some Americans still are in, to anger and bargaining and depression. And what we really need in the issue of climate is to get everybody to that 5th stage of saying, this is the world we now have, and we have a lot of opportunity to fix it, but we just plain have to get to work and organize and coordinate and prioritize what we do. And I think that's, I'm sure, my last slide. Yep, so that's it from me.
Thank you very much, Dr. Renning. And I believe they have a few follow-up questions.
That's right. We do have a couple of questions. These are coming from, well, first of all, thank you very much, Mr. Running. I think everyone appreciates your having taken the time so far. These are some questions that were written by students and teachers that
Okay.
I'm going to pass on.
Do you want to start? Let's go with slides.
All right.
Hey, Doctor. So first of all, I would like to thank you for your great presentation. That was really interesting, especially because I'm not a science person, but it was nice to know that as a social scientist, I can still do something.
Yes.
And with that in mind, my question touches on both the environmental and the more social science. To what extent are environmental sustainability and economic health at odds with each other?
I think one of the most fundamental issues we have in policy today is this, I would call it obsession with economic growth. Every economist says we have to keep growing. President Obama, every day of the week, says something about more economic growth. And yet, economic theory and certainly global science says we can't grow forever. The world's not getting any bigger. And so I think one of the absolutely foundational theoretical problems is to think through a strategy of how humanity can sustain itself without trying to achieve endless economic growth. There are groups that talk about no growth economics or sustainable economics. If you're interested in that, you can do searches on these terms. And there are some groups that have worked on this for decades. But the main economists that run our governments are still obsessed with economic growth.
So I understand that it really seems as though economic growth and environmental sustainability are at odds with each other. But would you say that economic development, which is quite a different concept, these two are still incompatible?
Well, it can be. And what I see with these groups that try to think through limiting economic growth is they say what we need to do is separate, I think, let's use your terms, human development, education, creativity, things like that, separate those from activities that are consuming resources. Because to have an increase in human knowledge shouldn't require resource consumption, but certainly burning coal and digging copper and things like that do. And so I think part of what these groups that try to think through limiting economic growth, I think they take the path that you're suggesting of saying, let's reframe this as human development and look at development in ways other than pure economic measures. One of the things they always are looking at is governments always measure success with growth in GDP. Gross domestic product is what GDP is. And it's just a measure of economic activity, but it doesn't in any way measure these other human development issues like reducing infant mortality or educational achievement of the whole population, or those things aren't even in GDP at all. And so this is part of what we see is getting governments to literally choose better targets for the country of something other than simply GDP growth.
Well, that's a great answer. Thank you very much.
Hello, my name is Kaya Haida, and I have a question, and that is, what role, if any, do natural forces play in the current global warming and climate change situation?
It's hard to completely separate natural variability from the human-induced climate trend, because we know that there are warm and cold days, there's hot, there's dry and wet years, we can't completely perfectly make the separation, but we're confident that probably 90 to 95% of that warming trend is human-caused. That only maybe a very small amount might be natural.
Okay, thank you so much.
Hi. Alright, so my question was that, do Do you think there's one thing in particular that is most threatening to life on Earth, and what do you think that thing would be?
Well, when we look at the global warming issue, as I've said, sea level rise we think will cause the most damage. But if we were really to stay on what they call business as usual, just continuing to do what we do now, particularly in fossil fuel burning, probably what we worry about most is what they call runaway climate, where we could reach a point where the temperature would just increase at an accelerating rate, that all of the ice and snow on the entire planet would melt off and be in the ocean. If that happens, sea level goes up 100 meters. 100 meters. Think how much of Rio is going to be left at 100 meters of sea level rise. So I think that's what we worry about as being an ultimate catastrophe that we certainly need to avoid.
And if you could say something to people who don't believe that climate change and global warming are serious issues, what do you think that you would say to them?
Oh boy. I would simply say that every National Academy of Science in every country in the world has formally stated that this science is real. And if they somehow can't believe every scientific body in the world, then I'm not sure where they get their facts from.
All right, thank you very much.
Hello, Mr. Running. I have one question going back to your statements about food security and also in relation to Brazil. Brazil has a lot of potential agricultural land as far as we've found out. There is quite a precedent for potentially replicating that in Africa. And Africa is set to quadruple in population in this century. Do you think, I kind of have two questions now, do you think that that presents the best hope for food security over the next century, this expansion of agricultural land, as opposed to just increases in agricultural efficiency? And also, does global warming threaten that kind of development, since there are significant dry periods in both Brazil and Africa on this land? And would climate patterns change and negatively influence any kind of developments that we could have?
Right. You're fortunate that of every continent on Earth, the one continent that has, you might say, remaining capacity is South America. We see there to be potential for some fairly significant expansion of agriculture if it's needed in South America. With Africa, when you look at a map, the amount of land area they have available is not that huge. And it's also, as you point out, pretty dry and subject to pretty significant drought episodes. And so there's a little potential in Africa, but I think Brazil and Argentina have more just land area available than any place else on Earth. You go to Southeast Asia with 3 billion people in the Southeast Asian area. They are completely tapped out. They don't have one spare hectare anymore. And so I think this will be an example of where South America and Brazil and Argentina particularly may really end up being leaders in future food security issues by having land still available that could be put into agriculture. And then the choice is what exactly to grow and what market is going to be most valuable, either economically or important for humanity. And unfortunately, those might not be one and the same.
Thank you very much, Mr. Running.
Hello, congratulations once again on the presentation. So, I had two questions on general just energy production. So one of the questions comes from an article that I read that talked about the feasibility and the benefits of switching first to nuclear energy as a means to reduce the amount of carbon dioxide production. What are your views on nuclear energy as a whole?
Nuclear energy appears to be a viable source, certainly, of low carbon electric power. The problem is the nuclear energy industry seems unable to get the cost of nuclear power down. And so right now, nuclear energy is just being priced out of the market. For the extreme cost of building a nuclear power plant, you could buy solar panels for millions of houses, and it would be a safer investment than the nuclear plant. So until nuclear power shows a way of generating electricity at substantially cheaper prices than they have now, they're really not in the game anymore.
And my other question refers to something that's still theoretical, and that's nuclear fusion as a possible viable source of power in the future. If that's ever feasible, do you think that could help finish off our energy problems?
Well, there's a variety of technological advances in fission power, in fusion power that are being pursued. And if someone magically figured out all the problems, maybe they could be important. But meanwhile, all these more low technology solutions like wind turbines and solar panels are getting cheaper and cheaper and cheaper. And there's millions of them being built with almost no, risk to humanity the way nuclear energy provides. And so nuclear energy is just getting undercut by simpler, more viable technologies that are much, much cheaper. So even if someone, fusion would be nice if it was figured out, but it doesn't seem to happen.
I see. Well, thank you very much once again for your presentation and your answers.
Okay.
Hi, Dr. Running.
Hi.
Our question is this: how concerning to you is the discovery of methane leaking out of the now melting frozen terrain and warming ocean floors? And what other feedback loops, perhaps lesser known, can we expect in the future?
Our lab works up in the Arctic on the carbon cycle in the Arctic tundra, and so I really understand that permafrost and the methane clathrates of the high latitudes are a huge reservoir of methane and carbon, that if those mobilized into the atmosphere, we'd be in big trouble. And so that's not just a theoretical concept. We clearly understand what's up there, and that the Arctic is warming more quickly than anywhere else on Earth. And so this is part of where we as scientists see some real urgency in getting politicians to do big things, not little things.
Second question along those lines: could it be possible to create our own feedback loops for taking carbon out of the atmosphere on a massive scale?
Turns out Brazil is already doing that. It's called the Amazon forest. Now, we find that taking CO2 out of the atmosphere, the most obvious illustration of that is plant growth. And the Amazon is literally the largest body of plant growth on Earth. taking CO2 out of the atmosphere. Whether the biosphere could ever be enhanced enough to start drawing CO2 down is an interesting theoretical question for a carbon cycle model. I've never heard anybody ask it that way. It might be possible. People are studying how to take carbon dioxide out of the flue gas, out of the smokestacks of like a coal or gas power plant, and compressing it and using it in some ways. But to do that to the massive scale needed really doesn't seem that it would ever be economically viable. And so literally enhancing plant growth is probably the most realistic way to move towards that idea.
Okay, thank you. And I have a third question tying into something you were mentioning earlier about China producing 70% of its power from coal burning plants. I've also read that coal burning, even though it's releasing gases that are obviously causing global warming, it's also releasing sulfur dioxide, which may potentially be masking the warming effect. Correct? Elaborate a little bit about that.
Well, turns out I was in Beijing last week, and the air pollution load in Beijing of particulate, sulfur dioxide, and nitrous oxides is just incredible. You often can see less than 10 kilometers of visibility, and it just goes into the haze. And so in a regional sense, you can end up with a regional cooling simply because the sun, in fact, I'll give you an exact example from last week. Sometimes in the middle of the day, my body didn't even cast a shadow. Think how dim the light was down at the ground surface in the middle of the day and with the sun out. Because the pollution was so thick, I didn't even cast a shadow. So on a very local basis, you could have some cooling, but that tremendous greenhouse gas load circulates around the whole planet. And so that local cooling is completely eliminated by the global warming. Not to mention, not to mention the incredible health impact of that level of pollution. It's really unbelievable. Okay.
All right, thank you very much.
I'm going to be the last question, so and then we'll let you go. I'm going to put you on the spot a little bit. Of course, you were talking about this international collaboration as far as tackling the global, the climate change crisis. My question to you is, as we're not as inundated with it as you guys are, but as you guys are getting ready for the elections and these sorts of things, what candidate, because as far as in the United States, obviously they're kind of looked at as, in the eyes of the rest of the world, out of all the candidates that are available currently, you know, your Donald Trumps, your Bernie Sanders, your Hillary Clintons, who do you think is best, who's the best person to tackle this climate change issue, and why?
Well, the sad truth is that the Republican Party collectively seems unwilling to even talk rationally about this topic. And so you basically have to discount every one of the Republican candidates. And it's too bad. I know that a number, at least some of them individually, privately, will admit that they know this is a real issue, but they are so completely controlled by the fossil fuel politics that they just have to put this facade up in public. With the Democratic candidates, Hillary Clinton came out against the Keystone Pipeline just yesterday. Bernie Sanders has been talking appropriate things all along. Joe Biden, if he jumps in there, I think is certainly willing to continue the things that President Obama is doing now. And so I'm fairly confident that any Democratic candidate that gets elected will probably continue Obama policy. If a Republican gets elected, we just don't see, we literally need the rest of the world to just box them in a corner and not allow them out until they wise up. It just, I travel all over the world, and it's just embarrassing as hell. Every other country is waiting for our Congress to wake up. And it's even only half of our Congress. And yet in our political system, they are able to block any major progress. It's really embarrassing. I guess the other part of answer I'll say is that have you heard of all the divestment strategies of having different entities simply take their investment money out of fossil fuels? In the last 2 years, that's become a very big deal. You don't argue politics or nothing. You just say, I'm not willing to have my pension fund, for example, invested in your coal company. Well, I was watching just an hour ago a press conference from yesterday. They now have $2.6 trillion of investment fund money that is now dedicated to being taken out of fossil fuels. And so it could be that the financial world is going to force the politicians to do what needs to happen. And they are well on their way to doing it with this divestment program.
I've heard of the divestment program, but it makes sense. But we have students that have been here well after school, and I know you are a busy man. On behalf of the ERJ and everybody, you can't see everybody in the background, but thank you so much, Dr. Reddings. And just so you know, this will be part of the Gen Conference. We have, I believe, as of now, about between 200 and 300 students coming from all over South America, some even from North America, discussing things like climate change. And hopefully these guys will help to move us in the right direction as far as solving this problem that we all face as humanity. So thank you once again, and on behalf of ERJ and everybody here, awesome, appreciate it.
All right, over and out. This is fun.